This is question 18 from section 1 of the 2018 NSAA paper. In this question, we have 6 red and 6 green sweets which are put in a bag. And we're told that a random sweet is taken from the bag. And if the sweet's red, we stop. So no more sweets are taken. But if the sweet's green, it's not replaced. So i.e. we take it out of the bag and then we have 11 sweets. And another sweet is then taken. And then we just repeat this process again and again until a red sweet is taken and then we stop. And what we have to work out is the probability more green sweets are taken in total than red sweets. So how do we go about this? Because we've got an awful lot of information here that's a bit of a mess to interpret. Well, the first one's this: to find a probability more green sweets are taken than red. Well, we know if we take a red sweet at any point, no more sweets are taken. So we know that this process, you'll have one red sweet in the end, because whenever we get a red, we'll stop, and we must eventually get a red. So we know we have one red sweet, and so probability more green sweets is just probability we have at least 2 green sweets. So this is easier to work with, because we can model our process and essentially count up the probabilities as we get to the scenarios where we get 2 green sweets. So we start here, and what could happen? Well, we could get a red sweet, and that's the end of the process, and we've got no green. So we don't want this outcome, really. Or we could get a green. And from here, we could get a red, or we could get a green. Now, you could carry on here, but the thing is, once we've got to here, we know we've got 2 green sweets. So we know at the end, we'll certainly have at least 2 green sweets. So we just need to find the probability we get to here, and then we're done. So let's do that. So we start here, and we've got 6 of each. So the probability we get a red is a half, and the probability we get a green is a half. And now, we've got to be careful, because if we pick a green, it is not replaced, and another sweet is taken. So that means if we have 6 red and 6 green, we'll now have 6 red and 5 green, because one of the greens has been removed. So we've got 5 green and 6 red, and then we select at random again. So the chance we get a red is clearly 6 over 6 plus 5, so 6 over 11. And 5 over 11 for the green, for the same reason. So we've got our table here, and we will work out the probability of getting to here. So that's this, the probability of taking the first green sweet and then the second green sweet, half times 5 over 11, which simplifies to this, 5 over 22, just by times the numerators together, denominators together. And that's good news, because that's B in a multiple choice, so our answer is B.